Hello there, and welcome to Peaceful Cosmos. Tonight, we journey into the deep, not into a world of noise or panic, but into a realm older than forests, older than dinosaurs, older than the shape of the continents you know. A world patrolled by animals that have survived planetary catastrophe not once, but 5 separate times. Tonight, we meet the shark. When most people hear the word shark, the mind flashes to a silhouette, a triangle of teeth, a sudden strike. But that image is a fraction of the story. Sharks are not simply predators. They are evolutionary experiments refined across 400 million years. They are engineers of fluid dynamics, interpreters of electric whispers, navigators of invisible magnetic highways. So settle in. Let the day soften at its edges. Let your breathing slow as we descend. Ancient survivors of a changing planet. Long before the first tree rooted into soil, before reptiles walked across land, before dinosaurs ruled or vanished, sharks were already here. They moved through Devonian seas when continents were arranged in alien shapes. They endured the Permian mass extinction, the most devastating die-off in Earth's history. When nearly all marine species disappeared, ocean chemistry shifted, temperatures spiked, entire ecosystems collapsed. Sharks persisted. Why? Because they were never just one design. Some species hunted shallow coasts, others cruised deep basins. Some specialized narrowly, others fed opportunistically. Cartilage of skeletons, lighter than bone, made them energy-efficient swimmers during times when food was scarce. Resilience was built into their blueprint. Every shark you see today is the latest edition of a survival manual written across geologic time, built to breathe in motion. For many species, breathing and movement are inseparable. Water must flow continuously across gill surfaces for oxygen extraction. For so-called obligate ram ventilators, the simplest way to achieve this is forward motion. Swim and oxygen flows. Stop too long and oxygen drops. This design shapes behavior. Open water cruising, preference for currents, resting strategies that still allow passive flow. Constant motion is not restlessness, it is respiration. But the trade-off is powerful. A body built for perpetual motion is a body built for range. Distance becomes trivial. Oceans become navigable corridors. Reading electricity in the dark. Every living organism emits faint electrical signals, muscle contractions, nerve impulses, heartbeats. Sharks possess specialized electroreceptors called ampullae of Lorenzi. These jelly-filled canals allow them to detect minute electric fields, sometimes as small as a billionth of a volt. A fish buried in sand may be invisible to the eye. It is not invisible to electricity. At close range, a shark is reading the ocean like a live circuit board. In murky water, in darkness, in chaotic feeding moments when vision fails. To a shark, life hums. A nose that maps the sea. The ocean does not carry scent in straight lines. It braids it into turbulent plumes shaped by current and tide. A shark does not simply charge toward blood. It samples, angles into flow, resamples, adjusts, tracks gradients, reads chemistry with extraordinary sensitivity. Blood, stress pheromones, decay, spawning events, all become drifting signals. Water becomes a 3-dimensional map. Skin that engineers water. Run your hand against a shark's body the wrong way and it feels like sandpaper. That texture comes from microscopic dermal denticles, tooth-like scales that channel water along the body, reducing turbulence and drag. Engineers have studied these surfaces to inspire ship coatings, aircraft design, and competitive swimwear. Nature solved a fluid mechanics problem long before humans formalized equations for it. When a shark glides with minimal tail movement, you are witnessing optimized hydrodynamics. Older than trees. Shark ancestors appeared roughly 50 million years before the first true trees. Imagine a world of shallow seas filled with armored fish, but no forests on land. That is where this lineage began. Their history is not linear. Many forms vanished, others branched into modern lineages. But the central idea persisted. A streamlined predator, multisensory, adaptable, efficient. Evolution kept returning to that design because it worked. Diversity beyond the stereotype. Not all sharks are built alike. Some glow. In deep waters, species like the dwarf lantern shark produce bioluminescence. Counter-illumination erases silhouettes by matching faint surface light from below. Camouflage made of light itself. Some filter feed. The whale shark, the largest fish on Earth, consumes plankton. Its mouth filters microscopic life, turning drifting abundance into energy. Each individual spot pattern is unique for long-term identification by researchers. Some live for centuries. The Greenland shark inhabits cold northern waters and may live over 250 years. Slow growth, late maturity, extreme longevity shaped by frigid metabolism. Some are small enough to fit in your hand. The dwarf lantern shark hunts in darkness, glowing faintly to avoid detection from below. The word shark contains multitudes. Teeth on a conveyor belt. A shark's teeth are not permanent fixtures. Rows of replacement teeth develop continuously behind the functional row. When one breaks or falls out, another rotates forward. This is why fossil shark records are dominated by teeth. Cartilage rarely fossilizes. Teeth endure. A single shark may shed thousands in a lifetime. Maintenance is built into the system. Skeleton without bone. Sharks have no true bones. Their skeleton is composed of reinforced cartilage, lighter, flexible, and ideal for rapid turning and efficient swimming. Mineralization strengthens key areas without sacrificing weight advantage. It is not weakness. It is optimization for water. Reproduction, many strategies. Shark reproduction is astonishingly diverse. Some species give live birth. Others lay egg cases, often called mermaid's purses. In certain species, embryos consume unfertilized eggs for additional nutrition. In rare cases, larger embryos consume smaller siblings, a brutal but efficient strategy, producing fewer, stronger offspring. And in isolated cases, parthenogenesis, reproduction without males, has been documented in captivity. Reproductive biology reflects environmental trade-offs. Few young, high investment, slow recovery if populations decline. Navigators of the invisible. Sharks detect Earth's magnetic field. Magnetoreception allows them to sense geographic variation in magnetic intensity and inclination, effectively giving them a planetary scale compass. Tagging studies reveal migrations spanning thousands of kilometers. Some individuals follow seasonal routes with remarkable precision. The ocean may appear featureless. To a shark, it is layered with magnetic gradients and thermal corridors. Ecological architects. Sharks are not merely hunters, they are regulators. By removing sick or weak prey, they influence population health. By inducing fear, they alter grazing patterns of herbivores like turtles. This landscape of fear can protect seagrass beds and coral systems. When top predators decline, mid-level predators can increase, triggering cascading ecological shifts. Remove the stabilizer, and the system tilts. Misunderstood risk. Sharks, despite dramatic portrayals, most shark species are small and pose little to no threat to humans. Even larger species often investigate with exploratory bites in low visibility conditions, not sustained predation. The disparity between cinematic fear and ecological reality matters because fear drives policy, and policy shapes survival. Human impact. Modern threats are not seals or whales. They are fishing pressure, bycatch, thin trade, habitat loss. Many sharks mature late and reproduce slowly. Population recovery can take decades. A single longline can unintentionally capture numerous sharks targeting other species. Conservation tools exist. Circle hooks reduce deep hooking. Shark sanctuaries protect breeding grounds. Tagging reveals migration corridors. Ecotourism makes living sharks economically valuable, but enforcement requires commitment. Sharks survived asteroid impacts and mass extinctions. They are less adapted to industrial-scale extraction. Science and myth. Shark cartilage does not cure cancer. That persistent myth lacks scientific support and has fueled unnecessary harvesting. Sharks are extraordinary without embellishment. Their true biology is more fascinating than folklore. The deep unknown. In the late 19th century, scientists identified the megamouth shark, a large, previously unknown filter feeder. If a shark that size could remain undiscovered recently, what else remains unseen in the deep? Much of the ocean remains unexplored. Sharks remind us how incomplete our knowledge still is. As we drift back up, tonight we followed ancient lineages through extinction and survival. We traced electric whispers in sand. We watched plankton-feeding giants and glowing deep-sea hunters. We explored magnetic navigation, embryonic competition, cooperative feeding, and ecosystems balanced by the presence of predators. Now let it settle, like sediment falling through still water. Imagine a vast ocean under a dark sky, a single shape gliding below, not rushing, not hunting, simply moving with quiet precision through a world that has endured ice ages and volcanic winters. Let your breathing match that rhythm, slow, steady, ancient. If you found peace in this descent, there is another journey waiting for you here on Peaceful Cosmos. But for now, unclench your jaw, relax your shoulders. The ocean is vast, and it is still moving. Sleep well. Good night.